So hi, today we're going to be solving Cambridge IGCSE Chemistry Paper 4 Theory Extended February March 2024 and Paper 42. So basically this was a February March 2024 paper, and I personally like this paper a lot. This is a very interesting and very good paper and very good for practice. So I hope that you guys try to solve it before I do, and that's going to make you really good at chemistry. It's going to help you practice. Okay, so let's get started with the first question, which says iron ore contains iron 3 oxide Fe2O3. A blast furnace is used to extract iron from Fe2O3. This oxide is called hematite. Okay, this is called hematite and it is an oxide of iron. The equations for the reactions in the blast furnace are shown. You should be good enough to know these three equations. Carbon plus oxygen first forms carbon dioxide, then this carbon dioxide basically formed reacts with, there's an equation missing over here. ठीक है, एक equation जो missing है, it's basically this carbon dioxide formed reacts with more carbon to form carbon monoxide. Okay, and after carbon monoxide has been formed, this carbon monoxide basically reacts with your hematite to form your iron. Okay, equation 1 shows the combustion of carbon in the blast furnace. Equation 1, it's showing the combustion of carbon. Why is this combustion? Combustion is the burning of a substance in the presence of oxygen. So oxygen is present over here, that is why this is combustion. Name the substance which provides the carbon for this reaction. The substance that we use for carbon is called coke. C-O-K-E, the coke that you drink. So that's coke. Basically, can any one of you tell me why do you call it coke? That black bottle, that Coca-Cola thing that you drink, why do you call it coke? Because it contains carbonic acid. Okay, the bubbles you see, basically the fizz that comes up, what gas it is? Can any one of you tell me? That's carbon dioxide gas. In your fizzy drinks, carbon, may it be Coca-Cola, may it be Sprite, 7-Up or Fanta, whatever. The fizz that you see, that's carbon dioxide, and there is carbonic acid in those fizzy drinks. Okay, so that's why you call it coke. Okay, state the purpose of the combustion of carbon in the blast furnace. Okay, you should know, you should be proficient with this thing, that combustion is a which kind of reaction? You should know this thing. That's very common, that combustion is a exothermic reaction, and we all know that exothermic reactions release heat. So a combustion reaction would release heat. So the purpose of the combustion of carbon in the blast furnace is to release heat or to provide heat. Because look, the processes that we are doing in a blast furnace, the reduction of hematite, producing carbon monoxide, producing this thing that's called slag, and everything required to happen at a very high temperature. And look, the iron that we are forming inside, basically it's also molten. So we are doing all this at a very high temperature. So we need to make sure that we have high temperatures inside the furnace. That is why we do this exothermic reaction to release heat. Next, iron 3 oxide in iron ore is converted to iron when it reacts with carbon monoxide. That was exactly what I was telling you, that what's going to happen when this reaction is going to happen. Let me write it for you. Fe2O3 is going to react with carbon monoxide, 3 moles of carbon monoxide, to form 3 moles of Fe. 3 moles of Fe, wait a sec, okay, plus, no, sorry, 2 Fe, because I was just thinking that it's not balanced. Okay, 2 Fe and 3 carbon dioxide. Now it's fully balanced equation. Okay, calculate the percentage by mass of iron in iron 3 oxide Fe2O3. I guess that's very easy. Iron is 56. Okay, iron is 56, and over here we have 2 irons, so 56 times 2 upon the total. The total is, what's the total? The total of all this, it's basically this entire thing. So it's basically 2 times 56 plus 3 times 16. 3 times 16. Okay, you can do it like this, multiplied by 100%. So 2 times 56 and then 3 times 16. I'm very bad with calculations. 2 times 16, I think I'm doing something wrong. it's 2 times 56 and plus 3 times 16, it gives me 160. So 2 times 56 divided by 160 times 100. 70% I get my answer as. Okay, state the name of the iron ore which which consists mainly of iron 3 oxide. The iron ore is called hematite. Okay, describe how carbon monoxide is formed in the blast furnace. Carbon monoxide is formed by the reduction of carbon dioxide. Okay, you have to write this process, that it's formed by the reduction of carbon dioxide. How is carbon dioxide reduced? See over here. You have this carbon dioxide. You make this carbon dioxide react with oxygen, and not oxygen, sorry, with more carbon, and you form carbon monoxide. What basically is happening over here is that, look, try to understand. Over here, this carbon had oxygen, okay, and two oxygens, and over here the carbon lost its one oxygen, and now carbon only has one oxygen. So this carbon dioxide, it got reduced. It lost its one oxygen. So that is the reduction of carbon dioxide. Okay, write the simple equation to show the reaction that occurs when iron 3 oxide is converted to iron in a blast furnace. I just wrote it down, that you're going to have Fe2O3 and you're going to add carbon monoxide to it. Then you're going to form 2 moles of Fe plus 3 moles of carbon dioxide. Okay, name the chemical process. Why it's of 2 marks? Many people, if you might think, one is for writing the equation and the other mark is for balancing. Okay, name the chemical process which happens to iron when iron 3 oxide is converted to iron in the blast furnace. The chemical process which happens to iron 3 oxide. Now try to understand this over here. Iron had oxygen attached with it. And whenever you loss of oxygen, okay, your loss of oxygen is called reduction. So what's happening to iron 3 oxide? It's being reduced. Look, it had its oxygen, but over here it lost the oxygen. So what happened? It got reduced. So the chemical process which happens to iron when iron 3 oxide is converted to iron in the blast furnace is reduction. Okay, state the type of reaction shown by equation 2. Okay, let's see what kind of reaction is equation 2. Okay, you have your calcium carbonate, and basically when you heat it, because this is a thermal decomposition reaction, when you heat it, your carbonates, whenever you heat your carbonates, not very stable carbonates like potassium and sodium carbonates, they're extremely stable. So even if you heat them, heat is going to have no effect. But if you heat your calcium carbonate, your zinc carbonate, your lead carbonate, your iron carbonate, whatever carbonate you heat below potassium and sodium, what's going to happen, it's going to convert it in oxide and carbon dioxide. So basically it decomposes. This is decomposition of this thing. So the reaction that's happening in equation 2 is simply your thermal decomposition. Okay, a substance decomposing. Moving on, explain why the reaction in equation 3 can be described as an acid-base reaction. Okay, so we need to have an acid in it firstly. Second, we need to have a base in it, and that's how we're going to make an acid-base reaction. So let's see in equation 3. Okay, this is equation 3, and what's happening over here is that we have this oxide over here, that's calcium oxide. Okay, this oxide is calcium oxide, and calcium is a metal. Okay, and over here we have silicon dioxide, and silicon is a non-metal. So when a metal oxide and a non-metal oxide reacts, what's going to happen? That's going to be an acid-base reaction, because metal oxides are always basic in nature. Metal oxides are basic in nature, except a few that are amphoteric, but their majority are basic. A non-metallic oxide are acidic. So we have an acidic oxide and we have a basic oxide, and both are reacting to give us this calcium silicate. I hope you understand now why this is an acid-base reaction, because we're acidic and we have basic and acidic oxide. Okay, so we have to write over here that our calcium oxide is basic. You just have to tell this. And your silicon dioxide is acidic. And then you have to just tell that both of them reacts. Okay, state the chemical name of SiO2. Chemical name is going to be what we use in chemistry. So it's going to be one silicon, so silicon, and two oxygen, so we're going to use di. Di means two oxide. Okay, the common name given to CaSiO3, that's calcium silicate, which is the chemical name. Calcium silicate is the chemical name, and the common name is what we use commonly, that is slag, when it's formed in the blast furnace. So that's going to be slag. Okay, aluminum cannot be extracted from its ore using a blast furnace. State why aluminum is not extracted from its ore using a blast furnace. Why? Because in a blast furnace, we can only reduce substances, we can only extract substances that are less reactive than carbon. Because what we're using in a blast furnace is basically carbon. We're using a oxide of carbon to reduce this thing. Okay, so but since aluminum is more reactive than carbon, it cannot be used. The reason is simple. Aluminum has to be extracted by electrolysis. Aluminum is more reactive than carbon. That's simple and easy explanation. Name the process used to extract aluminum from its ore. That's what I've just told you, electrolysis. Okay, both iron 3 oxide and aluminum oxide contain metal ions with a charge of 3+. Okay, that's correct. Okay, write the electronic configuration of an aluminum 3+ ion. Okay, if you go to the periodic table, you're going to check that aluminum has this 27 and 13. Okay, this is the electronic configuration for aluminum, and I know it because when you've done a lot of practice, these things just come in your mind automatically. Okay, so this is the proton number of aluminum. Okay, that means that this number in a neutral aluminum atom equals to your electron number. But over here we have aluminum 3+, and 3+ means that it has lost 3 electrons. Why it has lost 3 electrons? Because you have 3 more protons than your electrons. This means you've lost 3 electrons. So 13 minus 3 is going to give me 10. So I have 10 electrons, and I have to just fit my 10 electrons. So 2 and 8. Here I go with my 10 electrons. Simple electronic configuration. Reduce the number of protons and electrons in an iron 3+ ion. Okay, we're going to go to the periodic table and check out the proton number of a iron 3+ ion. Okay, where is iron? Iron is 26, and iron 3+ means it has basically lost 3 electrons. 26 electrons it had, it has lost 3 electrons, so now it has 23, because 26 minus 3 gives me a 23. So proton are going to be 26, they remain the same, and electrons are going to be 23, 3 less than the protons. Okay, the elements in group VII, which is 5, 6, 7 of the periodic table, are known as halogens. Okay, halogens can form halides. Halide simply means chloridine, your fluoridine, your bromidine, your iodidine, all these ions. Identify the halogen with the lowest density at RTP. Okay, you should know the strength in halogens, that your fluorine, chlorine, bromine, iodine, as you go down the group, what happens is that their density increases. Fluorine is a gas. Okay, chlorine is a gas, but bromine, it turns out to be a liquid, and iodine, it turns out to be a solid. So as you go down the group, your density increases. So what's basically happening here is that as your density is increasing, so the halogen with the lowest density is going to be your top halogen. So it's going to be, because we have to identify the halogen, not the ion, so we're going to write fluorine. But if they said the halide means the halogen ion, so we had to write fluoride. Fluoride is the ion, and fluorine is the name of the halogen. State the appearance of bromine at RTP. That's easy. When they ask for appearance, you have to write the state and the color. So you have to write the color, which is red, brown, And that's part of the syllabus. If you have a strong grip on the syllabus, you've learned the syllabus, you should know this. And the state is a liquid. Okay. Use the periodic table to give the symbol of the halogen with the highest atomic number. Okay, symbol of the halogen with the highest atomic number. Halogen highest atomic number is this one. Okay, this has to be the highest atomic number, because as you go down, this is the atomic number. The top one over here is the atomic number. It's increasing as you're going down the group. So 1 and 17 is the greatest. So it's going to be TS. So we write TS. Okay. Reduce the number of occupied electron shells in an atom of this element. So in this TS thing, we have to write the number of occupied electron shells. Okay. How do we get the number of occupied electron shells? We look at the periods. The period number equals to the number of occupied electron shells. First period, then we have our second period, third period, fourth period, fifth period, sixth period, and seventh period. Since it's in period 7, it's going to have 7 occupied electron shells. So we're going to write 7 occupied electron shells. Okay. Bromine molecules have covalent bonding state. What is meant by the term covalent bond? You have to write that it means electrons shared between pair of electrons shared between two atoms to attain, many people mess up with this. They don't write to attain a noble gas electronic configuration. You have to write this thing. These 2 marks are going to be only gained when you write to gain noble gas electronic configuration. And if you don't trust me, just read the syllabus. It's just written there. Name one halide which bromine molecules can displace. Okay, in halogens, a more reactive halogen can displace a less reactive halogen. So any halogen that's going to be more reactive than bromine can displace bromine. And any halogen, this is fluorine, chlorine, bromine, iodine, and acetylene. So bromine can basically replace this and this. Why? Because they're below bromine. Any halogen that is below bromine, bromine can replace it. So it can replace this or either this. So the answer is going to be, it can either be I or halide. So it's going to be iodide. Don't write iodine. You have to write iodide. It's the name of the ion. Explain why bromine can displace the halide. Because bromine, it is more reactive. The more reactive you are, the more power you have, the more ions you can displace. Name a halide compound which can be used to detect the presence of water. Okay, so you use cobalt chloride ion. So you use cobalt chloride. I hope you remember, use cobalt chloride. Cobalt chloride in detecting the presence of water. It turns from blue to pink. And since it turns from blue to pink, we know that water is present. So the ion is going to be chloride ion. You might think of copper 2 sulfate, but copper 2 sulfate does not contain a halide ion. So no. Okay, calcium chloride is an ionic compound. Complete the dot and cross diagram in figure 2.1 for the ions in calcium chloride. Give the charges. Okay, chloride is going to be a -1, and calcium is going to be a 2+. And this is complete shell for calcium, but chloride is going to have 1 additional shell. And they're going to be 1, 2, 3, 4, 5, 6, 7 normal and 1 calcium. Chloride again, it's going to have 1, 2, 3, 4, 5, 6, 7 normal, its own electrons, and 1 from calcium. Because what's happening is calcium is given 1 electron to this ion, 1 electron to this chloride, and it has lost its 2 electrons which were previously in its last shell, and now it has become calcium 2+. And since these chlorides have gained 1 electron, it has become chloride -1. Aqueous lead 2 ions are added to aqueous chloride ions. Okay, you have lead 2 ions which are Pb2+ ions. You've added them to chloride ions. A white precipitate is formed of lead chloride. Name a lead compound which can be used in this reaction. Okay, so when you have to make an insoluble salt, because lead chloride, you should all know this, is insoluble if you have learned the solubility rules. So if you're making insoluble, you need two soluble substances. So lead ions have to be added from a compound that's soluble. So you can take either lead to nitrate or any other soluble lead compound, because all nitrates are soluble. So lead to nitrate is soluble. Write the ionic equation for this reaction, include state symbols. Ionic equation is extremely easy. So what you have is, you have your lead ions, Pb, 2 plus ions, and the state symbol is going to be aqueous because it's lead nitrate, it's going to be soluble. Plus you have your chloride ions, they also have to be aqueous, and what you're forming is PbCl2, that's going to be a solid. Done. 3 marks just for this. I believe that's easy as nothing. Okay, name one other insoluble chloride. Lead chloride and silver chloride. Silver chloride are insoluble. Okay, this question is about acids, bases and alkalis. Table 3.1 shows the pH values of substances. Define the term of base. Bases are proton acceptors. Bases are protons acceptors. They accept the protons. And acids are proton donors. State what is meant by the term alkali. Alkalis are basically your soluble bases. The bases that dissolve in water are called alkalis. For example, your lead oxide, PbO. This is insoluble. Okay, this is a... No, wait, I cannot take lead oxide because... Wait, it's an amphoteric oxide. So... Wait a sec, let me take... okay, let me take barium oxide. Okay, so it's going to be insoluble. So it's a base. Let me take copper oxide. It's very good. Okay, copper oxide. It's insoluble. So it's a base. But if I take NaO, sodium oxide, it's soluble. So it's an alkali. So that's the difference. Thymophthalene is an indicator. State the color of thymophthalene in a NaOH, which is an alkali. So it's going to be blue because thymophthalene is blue in alkali, and in acid, which is ethanoic acid, it's going to be colorless. I hope that's correct. Okay, use the information in table 3.1 to identify the substance with the highest concentration of H plus ions. A substance that's going to have a highest concentration of H plus ions is going to have the lowest pH, because that means it's the most acidic substance. So the substance, this HNO3, that is going to have highest amount of H plus ions because it has the lowest concentration. HNO3, the explanation is going to be that it has the lowest pH value. Okay, name an indicator which can be used to identify the substance with the highest concentration of H plus ion. That is universal indicator. Why universal indicator? Why not thymophthalene? Why not methyl orange? That's a lovely question that I always love to respond. And I always tell people that, think about it. Okay, you have HCl and you have HNO3. Both are acidic. HCl, for instance, is a strong acid. But if you add methyl orange, which is red in acid, it's going to be red in HCl as well and HNO3 as well. Okay, whether an acid is strong or weak, methyl orange is going to be red in both cases. But if you add your universal indicator, it's going to be dark red in HCl and orange or light red in HNO3. So you know that HCl is a strong acid. And when you know that which one is the strong acid, you can basically reduce the concentration of your H plus ions. Okay, so that is what I would like you guys to know, that all other indicators, they just have two colors, one in acid, one in alkali. But universal indicator, it has a range of pH and colors which can tell you about every situation, either it's a strong acid or a weak acid. Okay, complete the equation to show the dissociation of ethanoic acid in aqueous solution. This dissociation, it has to be a partial dissociation because this ethanoic acid is considered a weak acid because all organic acids are weak acids. So you have to just draw this reversible reaction sign. You have to draw this ethanoate ion, which is going to be negative ion, plus your H plus ion. Okay, write the ionic equation which represents a neutralization reaction between any acid and any alkali. So the ionization equation is always this: H plus plus OH negative forms H2O, and that's the easiest. The neutralization equation. Okay, neutralization simply means that you have a acid H plus ion, you have an alkaline OH negative ion, and you're forming water out of it. Okay, now we have some moles. Okay, we have 5 marks just for doing the correct moles, and then we're gonna have, this is a really good question. Okay, let's do the moles and move on to a really good question. Okay, dilute nitric acid HNO3 reacts with aqueous calcium hydroxide. Okay, this is the equation. Equation is the single most important thing in every reaction. And why is that? Because equation gives you this, what I'm highlighting. And what is this? This is basically your amount or the moles in which the substance react. You know that 2 moles of HNO3 are going to react with 1 mole of calcium hydroxide, going to form 1 mole of calcium nitrate and 2 moles of water. Okay, so now even if you know the mole of any one substance, you can find out that the moles of calcium hydroxide are going to be half that of nitric acid. Okay, 20 cm cube of 0.0150 okay moles of calcium hydroxide react with this volume of HNO3. Calculate the concentration of HNO3. Easy peasy lemon squeezy. Let's just do it. We have to calculate the moles of this. So moles equals to your concentration 0.0150 times your volume, which is 20 divided by 1000. Y divided by 1000, this is in cm cube. We always take the volume in dm cube, so it's going to be 0.0150 multiplied by 20 divided by 1000. That gives me 0.0003. So my moles come out to be 0.0003. 0003. Determine the moles of HNO3. HNO3 moles are basically double that of calcium hydroxide. Okay, you can see it yourself. So the ratio is that HNO3 are double. So these moles multiplied by 2 are going to give me my HNO3 moles, which is 0.0006. Calculate the concentration of HNO3 in mole per dm cube. Concentration is going to be basically my moles divided by my volume. So moles are 0.0006 divided by my volume. Volume is 25, but I'm not going to take 25. I'm going to take 25 divided by 1000. 1 2 3 0.025. So 0.025 divided by 0.025, that gives me 0.024. Now I have to calculate the concentration in grams. So I have 0.024 mole, and I have to convert this into my gram. How do I convert moles into gram? Mass equals to moles times my mr. So moles are 0.024, and the mr of this thing is going to be, hydrogen is 1 plus nitrogen is 14 and oxygen is 16. So 3 times 16 because I have 3 oxygen. So 1 plus 14 plus 3 times 16. So 1 plus 14 plus 3 times 16, that's 63 multiplied by 63. 0.024, that gives me 1.512. I hope I've done it correctly, because I'm not very good at calculations. I'd agree to it. I can do all the chemistry, but calculations, balancing it, just all I'm not very proficient at it, because I usually make the calculation errors. So I'm sorry if that's the case. Okay, the equation for the reaction between methanoic acid and ethanol in the presence of a catalyst can be represented as shown. So this is the equation, it's shown. X represents the ester form. So what kind of ester are we forming? We have our methanoic acid and we have our ethanol. So we're forming ethyl methanoate. Okay, X is the ester. In the equation, this is a reversible reaction. Okay, in the equation, methanoic acid is represented by the formula. This type of formula. This is called the structural formula. This is called the structural formula. And how do I know this? This is called the structural formula because you have a full structure shown in it. First it's H, then it's C, then it's 2 O's, and then it's H. So it's a structure shown. Okay, write the empirical formula of methanoic acid. Okay, so the empirical formula is going to be, look, first let's write the molecular formula. Molecular formula is CH2O2. So now if we try to cut it down, okay, we cannot cut it down. So the molecular formula and the empirical formula are going to be same. So it's going to be CH2 and O2. or CO2H2. You can also write like CO2 and H2, but this feels a bit weird, so CH2 and O2. Okay, name and draw the displayed formula of ester X. Ester X was, what was it? We had methanoic acid and ethanol, so it had to be ethyl methanoate. Okay, it had to be ethyl methanoate. Okay, ethyl means that we have 2 carbon alcohols, something like this, and methanoate means that we have a 1 carbon acid. So this is ethyl methanoate. And in case you are worried, this part is your methanoic acid part and this part is your ethanol part. Okay, I hope you get it now. Okay, the reaction is reversible and reaches equilibrium when in a closed system state. What is meant by the term closed system? Closed system means that nothing enters or leaves the system. Okay, nothing entered or leaves the system. System is completely isolated. There are 2 characteristics of a equilibrium. Equilibrium means that your rate of forward reaction, okay, the rate at which the forward reaction is proceeding equals to the rate of backward reaction. Okay, so you have to keep this thing in mind, equals to the rate of backward reaction. And the condition for equilibrium, there are 2 conditions. Please learn these 2 conditions, they're widely tested. Rate of forward reaction equals to rate of backward reaction, and the second one was that your concentration of products and reactants are no longer changing. Okay, complete table 4.1 to show the effect, if any, on the concentration of X. X is basically on the concentration of X at equilibrium for each of the condition. X is your ester. Okay, you have to tell, because it's a reversible reaction, you have to tell what will happen if we change the condition to the amount of your X. Temperature is decreased. Okay, so this is what we are concerned about. Temperature is decreased. Okay, forward reaction, first let's just draw what we know. It's a forward reaction is exo, because that's a negative sign, and backward is endo. So when we basically, temperature is decreased or increased, we are decreasing temperature. So when we decrease temperature, when I try to lower it, equilibrium will try to increase it. Okay, you know this Le Chatelier's principle or whatever, that whatever you try to do to the equilibrium tries to reverse it. It tries to do something against it. So if I try to decrease the temperature, equilibrium will want to increase. If I try to increase, equilibrium will try to decrease. So I try to decrease, so equilibrium will try to increase the temperature. It would want more temperature because I have tried to lower it down. Now it will try to higher it up. So what will happen to increase the temperature? It will do exothermic reaction, because exothermic reaction is going to release heat. And when it does exothermic reaction, it moves forward, the concentration of X is going to be increased. So what happens to the concentration of X? It's going to be increased. Concentration of HCOH is decreased. Okay, the concentration of this thing is decreased. Okay, this is decreased, and when I try to decrease it, what will equilibrium do? Equilibrium will try to increase it, and to increase it, it will move backwards, and when equilibrium move backwards, X amount of X is gonna decrease. So X is gonna decrease. Okay, next, concentrations of both HCOH and CH3CH2 are decreased. When both are decreased, when I decrease this as well as this, now both of them, they go low. This also goes low. When I try to decrease it, equilibrium will try to increase it, and when equilibrium tries to increase it, it's gonna move backwards. Why it's gonna move backwards? Because it will form more of this thing, and when it moves backwards, X is again gonna decrease. Okay, I hope you are understanding this. Okay, the catalyst is removed. A catalyst has unfortunately no effect on the concentration of any substance at the equilibrium. Not only the concentration of X, but the concentration of any substance at the equilibrium. X is going to have, catalyst is going to have no effect. So we're going to write no effect or no change, right? No change. Okay. One of my favorite question, I guess, in the history of examination. This one's a really good question, okay? This displayed formula thing and everything. So try to pay attention over here. I love such questions. Okay, butane and butanene are colorless gases at room temperature and pressure. Okay, butane we have, which is an alkane, and butanene, which is an alkene. So just why butanene diffuses quicker than butane? I'd love to know the answers. Butanene, what's the molecular formula? C4H8. Okay, butane, what's the molecular formula? C4H10. Now look at the MR. This butane has 2 more carbons, and when it has not carbons, sorry, what I'm doing, 2 more hydrogens, and when it has 2 more hydrogens, that means it has more relative molecular mass, and when it has a greater relative molecular mass, it's going to be a heavier gas, so it's going to diffuse slower. So butanene, why it diffuses faster? Because butanene has a lower relative molecular mass, not relative atomic you're going to write, because we're dealing with molecules over here. Has a lower relative molecular mass, and you know, the more molecular mass you have, the slower you diffuse, and the lighter you are, the faster you diffuse. Identify the products formed when butane undergoes complete combustion. The product's complete word over here is extremely important. Complete means that we are going to form carbon dioxide, not carbon monoxide. The products are going to be carbon dioxide and water. Okay, 1 molecule of butane reacts with 1 molecule of chlorine in the presence of ultraviolet light. So what's basically happening is that you have an alkane, which is your butane, and then you have your chlorine, which is a halogen. During a reaction, which is called a substitution reaction, 1 hydrogen atom of butane is replaced by 1 chlorine atom. A substitution reaction. Name the type of reaction which needs ultraviolet light. It's called a photochemical reaction. A photochemical reaction is a reaction that requires ultraviolet light. State the purpose of ultraviolet light during this reaction: to provide activation energy. Okay, so basically, why do you use your ultraviolet light? It provides the activation energy. It is the minimum amount of energy required to basically make the molecules or the atoms or whatever, the colliding particles, react. Because you know, every time the particle, these are 2 particles, they collide with each other, they are not going to react or form a product. They're only going to form a product when they react with enough energy that's equal to the activation energy. Okay, name the type of reaction which takes place when 1 atom of chlorine replaces 1 atom of hydrogen. That's a substitution reaction. Why substitution? One is being substituted by the other. Determine how many different structural isomers can form during this reaction. Okay, so what we are doing is that we are taking a molecule of butane and we are replacing it with chlorine. So either we can form 1 chlorobutane or 2 chlorobutane, because there are no more possibilities. And let me draw it for you. Okay, look, we have 4 carbons, like 1, 2, 3 and 4. Either a chlorine can attach on the first carbon, okay, or if it doesn't, it can attach on a second carbon, okay. And if it doesn't, you might think that it can also attach on the third carbon. Okay, let me draw it for a minute, and you can also think that it may attach on the fourth carbon, something like this. But look, if this is the condition, we call it 1 chlorobutane because the chlorine is on the first carbon. If this is the condition, we call it 2 chlorobutane. Why 2 chlorobutane? Because chlorine is on the second carbon. And if this is the condition, we again call it 2 chlorobutane. Why 2 chlorobutane? Because we start the counting this from this side this time, from the left side. This is the 1, this is the second carbon. So we start the counting from the side from where chlorine can get the quickest. We can get to the chlorine the quickest. Over here, it's again going to be 1 chlorobutane. So there are only 2 possible structural isomers that are Determine how many different structure isomers can form. Only two. When butene reacts with steam, two possible products can form. It can be butane 1-ol or butane 2-ol. Identify the type of catalyst which is used. We basically use phosphoric acid catalyst, so you can only write acid catalyst. That's also going to be considered correct. Okay. Name and draw the displayed formula of the two possible products. Okay, we have to write the two possible products. So what basically happens is that you have your butene. Butene is something like you have 1, 2, 3, 4, and either your OH from the steam can attach on the first carbon, which can form butane 1-ol, or it can attach on the second carbon and form butane 2-ol. If it attaches on the third carbon, it will again become butane 2-ol, because now you start the counting from the left. This one's your first, this one's your second. So we have to basically write butane 1-ol and butane 2-ol. So butane 1-ol is going to be 1, 2, 3, and 4, and OH on the first carbon, and the remaining you have to draw all the hydrogen. But I'm doing something incorrect. If someone of you can point out what I'm doing incorrect, that's going to be a genius, because this is incorrect. Displayed formula means that I cannot write OH like this. I cannot write OH like this. This is going to be considered incorrect. I have to show the O and H bond something like this. Displayed formula means that all bonds, regardless of what kind of bonds they are, they have to be shown. So OH has to be written like this in case of butane 2-ol and butane 1-ol. Okay, so I hope you get this thing. Now moving on. But1ene undergoes polymerization. State the type of polymerization but1ene goes. When you have ene, you have a carbon-carbon double bond. So that's going to be a addition polymerization. Okay. Draw part of the polymer to show 3 repeat units. Okay, now first let's draw but1ene. But1ene is something going to be like this and this. So this is your but1ene. And now you try to bring it in the standard form for addition polymerization. What you do is that you pick up the entire thing that is attached with this carbon and bring it over here. Why? Because you need this double bond in the center. Okay, the double bond should be in the center. So you pick up the entire thing and bring it below the carbon. So this is basically C2 and H, 1, 2, 3, 4, and 5. So C2H5 basically comes over here, C2 and H5. And this one gets erased. Okay, you erase it. And now you have one repeat unit. And you bring this H down, because whenever you are making repeat units, always remember that either the thing has to be above carbon or below carbon. These ends should be free, because this is from where you have to draw the extension bond. So you erase this hydrogen from here, you draw this hydrogen here, and now you have one repeat unit. You basically break the double bond from here and you extend these bonds. So now you have to just draw 3 repeat units like this. So this is going to be H, there's going to be C2H5, H1 repeat unit. Now let's draw the second one, H and C2H5, then H and H, the second repeat unit's done. Now let's draw the third one, H, C2H5, carbon, H and H, and now these extension bonds. So 3 repeat units are done. Erase this thing which you have done for understanding, because the examiner might consider it as your answer. It's important to draw these extension bonds as they contain marks, and we are done with our paper, I guess. And hope you liked it. Do consider subscribing to the channel. That's going to mean a lot. Bye-bye.